more time, is this clear? Is the du clear to everyone? So remember, dy or du or dt, whatever, is the derivative times dx. So the derivative of u is 2x, but I need, because it's du, this is not u prime. U prime will be just 2x, but we want du because we need du in the integral. So this is 2x dx. So now I have the product x dx, which is this. When I want to solve for this, I divide both sides by 2. I put 1/2 in front. Which function I differentiate to get u to the 7th? Anyone, please. Which function we differentiate to get u to the 7th power?
U to the 8th over 8.
Excellent. Very good. Thank you so much. U to the 8th over 8. Of course, plus a constant c because this is indefinite. I multiply here to get 1 over 16. But u has to be replaced by x squared minus 6. So this is x squared minus 6, x squared minus 6 to the 8th power plus c. So whenever we use a substitution for an indefinite integral in x, the answer at the very end has to be in x. It's okay that we use the substitution, otherwise we would have had difficulties. We would have encountered difficulties in getting here, but after we use the substitution, we have to replace it back because the integral was given to us in x. That's the reason why we have to have the answer in x as well. And this is it. And we illustrated with an indefinite integral. And let's illustrate with another one. So please choose another indefinite integral, because also we have the substitution rule for definite integrals. Any preference? Let's choose another indefinite. And then we'll look at the definite ones on Thursday. Anyone would like to choose another indefinite one? Okay, I will choose 15. So the integral from x to the 4th times e to x to the 5th dx. We have to come up with a substitution. Which substitution do you think we should use? So here's how I look at it. I look at x to the 4th. There is not really nothing I can do to x to the 4th. It's a friendly quantity. So it can stay. But when I look at e to x to the 5th, I realize that I really don't like it because it's a function that has another function in it. I like e to the x. That's fine, plain and simple. I don't like e raised to x to the 5th power. This is complicated. It's a function, this is the inner function, plugged in e to the x. I don't like this. So what do you think u should be to make the integral as simple as possible?
E to x to the 5th.
Just the x to the 5th.
Okay.
Because that's what bothers me. I like this. I like e to u, but I don't like e to blah, blah, blah. So we will denote this too by u. Okay, remember we need the du. We cannot continue before we determine du. Can anyone determine for this function du, which is not the derivative? It's the differential. Can anyone give us the differential for this function? please. What is the derivative? Before we write the differential, what is the derivative of this function?
5x.
5?
4 power.
Yes. All you have to do is just multiply by dx. That's it. So coming back here, we have the indefinite integral. What do I replace this by? Just
E
this.
to u.
Exactly. Now we have to think. I have an x to the fourth, and I have dx. What do I replace x to the fourth dx by? This piece.
du. Oh,
Yes,
5.
du over 5, indeed. Put 1/5 outside, the integral from e to u du. So much easier than all this. Okay, so then we have 1/5. Which function prime is e to u? There is one function that we differentiate to get e to u.
E to u.
E to u plus a constant c because it's an indefinite. However, we have to go back to our substitution because the integral was given in x. The answer has to be in x. So what do I replace u by? Plus a constant c.